In this tutorial, you will build an NFT Minter. This will be a full dApp with a frontend and a smart contract deployed on Ethereum. We will use Solidity, React, Web3, Metamask, and Alchemy, one of the most powerful platforms for blockchain development. If you are new here, I'm Julian, and on Hit the Blocks, I teach blockchain development. Before we start the coding, it's important to understand how making an NFT works. It involves two steps. First, you publish an NFT smart contract on the Ethereum blockchain. Usually, this is going to be an ERC-721 or an ERC-1155 token. And the second step, once your NFT smart contract is deployed, you call the minting function on this NFT smart contract to mint your NFT. So minting just means creating a new NFT. Usually, this minting function requires you to pass two variables. First, the recipient, which specifies the address that will receive the NFT, and second, the NFT token URI. This URI points to a server that returns a JSON document that describes the NFT metadata. So for this tutorial, we're going to focus on part 2 by calling an existing NFT smart contract. So we're not going to deploy our own NFT. So this is the NFT that we are going to use, and it's deployed on the Ropsten network, a testnet of Ethereum. Okay, so now we understand how making an NFT works. Next, we're going to start the coding. First, go to the GitHub repo of this tutorial to get the starter files for this project. So you're going to need to copy the URL and clone the repo in your terminal. There are two folders. Minter starter files. This is some boilerplate code that we're going to use to get started. And NFT Minter, this is the final code in case you are lost in a tutorial. So we go into Minter starter files, and then we're going to open this with a code editor. So here I use VS Code, but feel free to use whatever code editor you want. Before we start adding new code, let's check out what's in the boilerplate code. So first of all, we are going to run our project in Minter starter files. We're going to install the dependencies with npm install. All right, so now we're going to start the server with npm start. And now in your browser at localhost:3000, you should see this. That's the front end. So we have a button to connect the wallet. And then we have a form to mint the NFT. So here we have a URL to the image of the NFT, the name of the NFT, the description, and then you have a mint button. So now let's check out the code in the src directory. So most of the code is in Minter.js. So first of all, we define a couple of state variables, the address of the wallet, then the status, that's a string that is displayed in the UI, then the name of the NFT, the description, the URL of the image. Then we have a couple of functions that we're going to implement later. Connect wallet press, this is the callback when we click on the connect button. This is the callback when we click on the mint NFT button. And after we have the HTML, so here the button to connect the wallet. Then we have the form to create the NFT with the different input. The input for the image of the NFT, the input for the name, for the description, and finally the button to mint the NFT. For users to be able to interact with your smart contract, they will need to connect the Ethereum wallet to your dApp. And for this tutorial, we will use Metamask, a virtual wallet in a browser that is used to manage your Ethereum address. If you don't have Metamask already installed, you need to go to the Chrome Web Store, search for Metamask and install it. When you are just learning and you follow a tutorial, you shouldn't use the real Ethereum network that we call mainnet. Developing on mainnet is very expensive, and if you make mistake, you're going to lose some real money. So instead, we are going to use Ropsten, which is a public testnet of Ethereum. On Ropsten, we don't manipulate real Ether, and any mistake that we do here doesn't have any consequence for Ethereum mainnet. So this is a good playground for developing. And on Ropsten, we can get some free Ether by using a faucet. And all we have to do is to copy and paste our address. So for that, you will need to open Metamask by clicking on the Fox icon in your extension menu, and you select the Ropsten network, and you are going to select the first account and you're going to copy it to the clipboard, and then you're going to paste it in the Ropsten faucet. You click on send me some test ether, and when you see your address in last deposit, it means that the ether was sent to you. And so next, to verify that you did receive some ether in your wallet, you can use a tool provided by Alchemy. So you select Ethereum Ropsten, get balance, and here you're going to copy paste your address, and we're going to click on send request. And here we see our balance. So this is in hexadecimal, but this, we can see that this is not 0, or more simply, you can see this in MetaMask. Here we can see that we received some ether. So now that our MetaMask wallet is set up, we're going to connect our dApp to it. So first, you are going to create a utils folder in the src directory, and you're going to create a file called interact.js, and it's going to contain all of our wallet and smart contract interaction function. So in interact.js, we'll write a connect wallet function that will later import and use in our Minter component. So we are going to copy paste directly the code for the connect wallet function, and for that, you can copy the code directly from the written tutorial on the website of Alchemy. You go to step 4, you scroll down, and you will see the code for connect wallet. So you copy this code and you paste it in your code editor. All right, so let's walk through the code of this function. So first, in this if, we are testing if MetaMask is injected. If that's the case, the Ethereum object is going to be injected. Then we are going to ask MetaMask to give us the list of address of the user with window.ethereum.request, and then we extract the first address of this array, we put it in an object, and we return this object. Otherwise, if the try catch block fails, then we're going to return the error message. And otherwise, if we're in this else branch here, that means that MetaMask is not installed. And so in this case, we are going to prompt the user to install MetaMask with a link to the MetaMask download here. All right, so back to the tutorial of Alchemy. So let's scroll down. And after, we're gonna make use of this function in Minter.js. So for that, we need to first import this function in Minter.js. So we go back to our code, we go to Minter.js at the very top, and we're going to import connect wallet, then back to the tutorial, and we're going to copy the code for a new function, connect wallet pressed. And so this is the function that's going to be called when we click on the connect button to connect MetaMask. So let's copy this, and it's going to replace here the skeleton for this function. So we're going to call connect wallet that we just defined before, and we're going to update our state for the status and for the address of the wallet, and the connect button is going to show us the address of MetaMask. All right, so let's save these two files, and after, let's go to our front end. So let's make sure that we are on the correct network. Yes, Ropsten with account 1. Okay, so we are going to click on connect wallet, and then we're going to have the pop-up of MetaMask. So we select the correct account, next, and basically when we click on connect, we will allow our dApp to see our Ethereum address. So click on connect, and now we can see our button has changed and we can see our address here. Cool, so it's working, but there is a problem, because if we reload the page, then it doesn't remember that we are connected. We see the connect wallet button like at the beginning. So we will need to add some code to fix this problem. So we go back to the tutorial, and we're going to add this function get current wallet connected. And this function is going to be executed when we first load our app, and it's going to tell us if we are already connected. So let's copy this, and we go in our code in interact.js, and we're going to add this new function, get current wallet connected. So first, if MetaMask is installed, then it's going to try to get the list of accounts. So this is a different method that what we used before. This is eth_account. So this is going to give us the list of accounts if we are already connected, but this is different from what we had before, which was request accounts. This is going to prompt the user to connect the account. So in this case, we only get the list of accounts if we are already connected. And if this array has a length superior to 0, that means we are already connected. And in this case, we just return the first address of the array. Otherwise, that means we are not connected. And here we also have a catch block if we have an error. And finally, if we are in the else branch, that means MetaMask is not installed. So we're going to prompt the user to install MetaMask. All right, so now we need to make use of this function in our Minter component. So let's go back to the tutorial. And now we are going to update our import in the Minter component. Let's go back in the Minter component. And here we're going to update this part. All right, now we're going to make use of this get current wallet connected function. And so for that, we're going to copy this code, use effect. Let's scroll down. So here, let's replace this, use effect. So this function is going to be called when we first load our component. And so first is going to try to get the current wallet connected, and it's going to update the state. All right, so let's save this. And now let's go back to our front end. So let's reload our front end, and now we can see that the button is working. It detects that we are already connected. All right, so we fixed the problem, but now we still have an issue. What if we change the address in MetaMask? Now MetaMask and our dApp will be out of sync. So we need to react to address change of the user in MetaMask. So for that, we go back to the tutorial, and we're going to add this function, add wallet listener. So we are going to copy paste this function. Then inside Minter.js, we're going to define this function here. So let's see what it does. So if MetaMask is installed, we're going to listen to an event of MetaMask called account changed. And every time the accounts are changed, this callback is going to be fired with the new list of accounts. And the new account is always the first entry of the array. And after we update the state of our component, and here if we are in the else, that means we don't have MetaMask installed. And so now we need to execute this function. So let's scroll down, and here we need to trigger this function at the end of the use effect. So back in our code, and here let's call add wallet listener here. All right, so we have finished the wallet functionality. Congrats. Metadata allow an NFT to have properties such as name, description, and other attributes. So all this metadata will be in a JSON object that is going to be accessible at a specific URL. That's the token URI parameter that we pass to the mintNFT function. We could store this JSON object on the Ethereum blockchain, but if we did so, it would be really expensive. We could also store this on a centralized server like AWS or Firebase, but it doesn't respect the decentralization ethos of the blockchain. So instead, we are going to use IPFS, which is a decentralized protocol and peer-to-peer network for storing and sharing data in a distributed file system. So we can use IPFS directly, but if we want our data to be persistent, we have to use a feature of IPFS called pinning. And for this, we need to run our own IPFS node. So instead, we can do something more simple by using Pinata, which is a service to use IPFS simply. So with Pinata, you can store anything you want on IPFS, and Pinata run their own IPFS node and transparently allow you to use the pinning function. So that's what we're going to do in the next step. If you don't have a Pinata account, first you need to sign up for a free account. And after you go to your dashboard and you go to the API keys menu and you create a new key. So here you toggle the admin key option. It's going to enable enough capability for your API key. And here you give it whatever name you want. So tutorial here. All right, and here you scroll down, you click on copy all, and you paste this somewhere. And after, we're gonna pass these secrets to our application. So for that, first we are going to install a new dependency. So let's open a new terminal, and we're going to install npm install.env. So that's a dependency to manage environment variable in your application. All right, and after that, we are going to create a file for environment variable. So we're going to create this file at the root of our project .env, and then inside we're going to create two environment variables. So let's see the tutorial to see the correct name. So here, React app Pinata key. All right, so let's copy paste this from our note. And for the secret, this one here. All right, and after, we are going to create a function to upload a JSON to IPFS by using Pinata. And Pinata has an API specifically for uploading JSON data, so it's going to be easier. So we're going to create a new file, Pinata.js, and we're going to copy paste this code. So we go in src utils and we create a new file, Pinata.js. So here we use the .env npm package. This allows us to load automatically in our application the environment variable of the .env file. And here we extract these two environment variable in local variable. And after, we're going to create our function to upload the JSON. So we're going to copy all of this. All right, so let's see what this function does. So first of all, we import Axios, which is an npm library to do HTTP call. Then after, we define our pin JSON to IPFS function. So you receive in argument the JSON object that you want to store. Then this is the URL for the API of Pinata, and it has an endpoint which is called pin JSON to IPFS. And here with Axios, we are going to send a post request to this URL with our JSON object. And in the headers, we specify the API key and the secret. And if this is a success, we are going to return from this function an object with the URL to our JSON data. And so Pinata make our data available with its gateway URL here. And we're going to use the response object to build this URL. And what's important here is the IPFS hash that is returned by Pinata. And after, we also catch the error here. Next, we need to find a way to call the mintNFT function of our smart contract from our frontend. So if you have a look at the files in our project, you will find that one of the files is called contract.abi.json. So this is a JSON object that describes the interface of our NFT smart contract, and we're going to need this to call the mintNFT function. We will also need a connection to the Ethereum blockchain, and for that, we will use the Alchemy API. So go to the website of Alchemy, create a free account, and in your dashboard, you are going to create a new app, and you need to choose Ethereum, and for the network, you're going to choose Robston. All right, so create app. So then we going to check the detail. We click on view key and we copy the HTTP endpoint. So this endpoint will allow us to access the Ethereum blockchain. Don't share. Then we go in our browser, then we go in our code editor, and we're going to open .env, and here we're going to define a new environment variable, React app Alchemy key. All right, and then we're going to copy some code from the tutorial. So let's go to step 7, scroll down. Okay, so first we need to install the Alchemy Web3 library to connect to the Ethereum blockchain. So Web3.js is a library to connect to the Ethereum blockchain, and Alchemy Web3 is an extended version of Web3 that supercharges Web3 with some functionalities provided by Alchemy. We go to our code editor, we go in the built-in terminal. Then we're going to add some code in our file interact.js. So we're going to copy this and we go in interact.js, and okay, let's minimize the terminal here, and at the top of interact.js we're going to paste this code. So first line, we activate the .env library to access the environment variable. We read the Alchemy key. We create Alchemy Web3 function from Alchemy Web3, and after we create our Web3 instance. So after, with this Web3 instance, we will be able to interact with the Ethereum blockchain. And so we're going to add some code in interact.js. So first we import the contract ABI, and then we define a variable with the address of our NFT smart contract. Inside the interact.js file, we're going to define a function that we'll call the mintNFT function of our smart contract. So let's go to the tutorial and we're going to copy the function signature. So it's going to receive the URL of Pinata, the name and description of the NFT. So first, we are going to check the argument that are provided. So if URL, description, or name are empty, then we are going to return an error. Then we are going to import a function from Pinata.js. After, we are going to use this function in mintNFT. So here we create an object with the different parameter that we pass as argument with the different parameter of the NFT. Then we call the pin.json to IPFS function and we pass the metadata. So at this point we have the metadata that is stored on IPFS, and we get the response from Pinata, including the URL to the JSON object. So if there is an error, we return an error. Otherwise, we extract the URL of Pinata. And after, we go back to the tutorial and we are going to copy another line of code. So we're going to instantiate a Web3 contract object. So that's with this object that we can interact with our NFT smart contract. So here we use Web3 that we instantiated before with the Alchemy Web3. We pass it the ABI and the address of the NFT. And after, we store this in the window object. And finally, we're going to use this object to interact with our smart contract. So here we're going to copy all of this. So first, we set up the parameter of our transaction, so the address of the smart contract, the sending address, and the data. So the data, that's how we specify which function we want to call in the smart contract and with which parameter. So for that, we call the mintNFT function here on our contract object, and we pass it the address of the recipient of the NFT plus the token plus the URL from IPFS. We call the encode ABI function. So it's going to encode this function call in the right format. And after, we are going to ask the user to sign this transaction by using Metamask. So we use the window.ethereum object to connect with Metamask. We specify we want to send a transaction and we pass the parameters. And if the transaction is a success, then we're going to show to the user a link to the transaction on Etherscan. Otherwise, we're going to show an error message. So now we're going to use our mintNFT function in the Minter component. So we go to the tutorial, step 9, and we're going to import the mintNFT function. So we go in Minter.js, we go at the top. We're going to replace our import here. We added mintNFT. Let's remove this. All right, back to the tutorial. And we're going to copy the code for the onMintPress function. So this is the callback function every time we press the mint button. Let's scroll down. All right, so let's replace this function by onMinPress. And so here we just call the mintNFT function with the parameter that we specify, that the user specified, and we update the status after the transaction is mined. So now that your app is ready, you can deploy it to a live website. Our app only has a React frontend, so you can use any service for hosting static frontends. I recommend either Vercel or Netlify. I've used both of them and they are simple to use. They have a free tier that will be enough for this tutorial. So when you create a new project with Vercel, you need to connect it to a Git repo, so it can be a bit more challenging if you never used Git before. On Netlify, however, you have the possibility to just drag and drop a folder. So in this case, you have to run the npm run build command at the root of the project, and it will produce a build folder with a deployable HTML and JavaScript file. So you just have to drag and drop this build folder to Netlify. Remember that we also have environment variables defined in a .env file. You will need to also pass these values to your frontend. So both Netlify and Vercel allow you to define environment variables. So you just have to make sure that you use the same name that we use in a .env file. And after you finish to do your deployment, you will have a custom URL with which you can access your app in a web browser. And if you want to do a real production deployment, you just have to add a DNS configuration so that your domain name points to Vercel or Netlify server, and after you will be done. So after you deploy the NFT Minter to a live website, you can use this app to deploy your own NFT. And after, you can visualize your NFT in a mobile version of Metamask. So for that, you need to install Metamask on mobile. It's available both on iOS and on Android. And after, on Metamask mobile, you need to set the network to Ropsten. Then once you're on the Ropsten network, you need to select the collectibles tab on the right, and you add the NFT smart contract address and the ID of your NFT, which you should be able to find on Etherscan based on the transaction hash that was provided to you when you minted your NFT. So you add the address of the NFT, of the ID of your NFT, and after, you should see your NFT in Metamask. Congrats for following up to here. Now you know how to build a full decentralized application on Ethereum. Together we have built an NFT Minter. We have covered the smart contract and the front end. We use React for the front end, Solidity and Hot Hat for the smart contract, and Alchemy for the connection to Ethereum. If you haven't signed up already, go to the website of Alchemy and create a free account. Alchemy is the AWS of blockchain, and it's going to be a massive time saver when you build blockchain application. You can also check out the written version of this tutorial on the website of Alchemy. I put all the links in the description down below. I hope you enjoyed this video. Keep learning, keep building, and see you soon.